All right, awesome. And we are live.
Hi, everyone. So I'm Nicole Hubbard, a developer advocate for HashiCorp. And joining me today, we have RB and Kit, two of the engineers on Consul. And so today we're going to be talking about some of the new features that we launched in Consul 1.8, which is currently out in beta right now. And so to get started, I'm just going to screen share some stuff and show our new WAN federation features. And so if we come over here, yeah, there we go. Make this a little bit bigger for us. All right, so what I've done is I have two Kubernetes clusters. So if we take a look at my Kubernetes context, I have a GKE cluster and an AKS cluster, and I'm currently connected to the GKE cluster. And what I've done is I've deployed our Consul Helm chart into both of these. And so this is the YAML file with our values that I deployed into our GKE cluster. So we're enabling TLS, we enable all of our Ackles, we enable federation, which is a new feature that we've recently added, as well as we're enabling the gossip encryption, as well as our existing connect, inject, and mesh gateway functionality. And so once we deploy this into the cluster, we can see that running, we have our Consul clients, we have our mesh gateways running, and then we have 3 Consul servers running. In addition to that, we've got a dashboard service that we've stood up so that it can register into the cluster. And after we've deployed that, what I did was I grabbed this Consul federation secret out of the cluster that is in our primary cluster that we create. So if we actually look at our secrets, we can see that exists right here. Oh, nope, that's the Consul federation. There we go. So I pull that token out, save it locally, and then we can switch over to our AKS cluster, and we can actually see that I've already applied it all, but what we do is we apply the Consul federation secret, and then we actually deploy our Helm chart with the values for AKS. And so there's a little bit more that we specify here, but it's pretty close to the same. The main differences are we're actually specifying what the certificates we're using are. So we pull them out of that federation token that we got from our primary cluster. We grab the CA key, we grab all of our replication tokens for the Ackles, we enable federation again. We also set some additional configuration for our federation to use some additional values so that we can actually load everything we need for federation out of that Consul federation token. And then once we've deployed that, which we've done, we can actually see here, we've got our Consul server running, we've got our mesh gateways running, and we've got our Consul clients running on each of the nodes, as well as a counting service. And so if we actually take a look at the services that we have running in this cluster publicly available, the only thing we've actually exposed to the internet is our mesh gateway itself. And so this is exposed, this is listening for incoming connections, and this is how our GKE cluster will connect. And so if we actually go over here to the browser, we can see that so I've got a port forward open to our GKE Consul cluster. And I can actually show that we have all of our nodes running here. So we've got our 3 GKE nodes in our cluster and our 3 Consul servers. And we can actually see our services. And we've got our mesh gateway, the dashboard service that we've deployed, and Consul. And we can actually see that we have AKS as well. And so these are communicating with one another over the public internet through those mesh gateways that we've deployed right here, with no additional firewall rules needed to open those services and to require that communication. And then from there, we can actually allow our dashboard service here in the GKE cluster to communicate with the counting service that's running in our AKS cluster over the mesh gateway. And so that's kind of an overview of how the new WAN federation works in Consul 1.8. To talk more about that is one of the engineers who built it, RB. So I'll let him take over now.
So
WAN federation is not necessarily something that's new to Consul. That's sort of one of those things that's been around forever. It's basically the way that you have two separate data centers, which is just co-located sets of servers, share information back and forth. In the pre-service mesh world, this is how you would have services in one facility maybe reach over some some VPN to another facility to access like some credit card service or billing service or whatever your company has. But it always required that all of the servers, those are the ones that do most of the raft manipulation and sort of maintain the whole cluster. Most of the servers on both facilities, both data centers, need to have a bunch of ports open to each other, so they can actually do a bunch of operations like a WAN, wide area network gossip, in order to exchange membership information like, hey, I'm here, I'm over here, this is my current IP address, I'm a server, back and forth. And to tell each other things like, I think that server over there has died. Yep, I can think he's dead. And then it takes them out of the membership. Similarly, RPCs, like Nicole was showing in the UI, whenever you access a foreign data center's information from a different data center, what actually happens is the RPC is forwarded over the public internet to the destination and proxied back. And all that requires yet another port open. And prior to 1.8, this was sort of a DIY process of punching all the holes or setting up VPNs or whatever you need to do in order to make all that transit work. And sometimes if you were running a firewall and had to lock everything down, it was sort of tedious to have the cross product of all the servers in one data center and all the servers in another data center and all the ports open for everything. And it started to look a little bit like Swiss cheese. So the new model has us repurposing a 1.6 feature, the mesh gateway, which we introduced for the data plane for all of the services to laterally talk to each other over the wild west of the internet through these mesh gateways. And repurpose that so that the servers could talk to each other through that mechanism. There's a little bit of chicken and egg setup in order to plumb it all together at the startup. And it's an interesting exercise in layer punching, I think, since the layer of Consul that deals with gossip is one of the foundational ones, and the layer of Consul that deals with the service mesh is a higher level construct, and we sort of thread one through the other, which is a little bit tricky. But at the end of the day, what happens is instead of having to punch several holes between all possible servers and all these different ports, making your security team a little bit sad, you only really have to punch holes necessary for the cross product of the mesh gateways to see each other. And because the mesh gateways are only speaking MTLS over the public internet, it's sort of secure by design, rather than you having to layer yet another like VPN on top of this stuff to make it safe. And then those are relatively fixed. You can sync those onto particular pinned nodes in both sides of the wide network. And the security team only has to monitor those egress points, and everything else can just operate over that sort of, it's almost like an application layer VPN that we've constructed, versus like a traditional kind of VPN. So that's the high level, I guess. I don't know if you want me to go into the really gross nitty gritty of how it actually works.
You're more than welcome to.
So when you say gross, like what do you mean?
Oh, well, Consul's an old product, right? And so there's a lot of the design decisions were from I think it may almost have been birthed around the same time as the clouds were becoming public.
It was like, yeah, like 2013. I think.
Yeah. So a lot
Yeah,
of the
gross was
design
pretty-
decisions were based around the whole static server. It's a big deal to move something between two servers. There's a heavyweight VM. Things tend to stay on a VM, so we can put these agents on the VM.
Yeah, this was way before it became like common practice to like bake an image and then just start it up from the image. So
Yeah,
it's
yeah.
still very high touch servers.
So there's lots of things that changed since 2014 or 2013 on the internet and the way we design stuff. And Consul's very backwards compatible. So we have to support all the old ways of doing stuff, and people still deploy this on bare metal today. So it still has to work. You also run it in the cloud, and there's lots of different ways that you can solve your variety of networking problems with Consul. So all these things have to still work. We'd like them to mostly still work even when we do this magic trick of sending server RPCs and gossip requests over the internet. Probably the more interesting one is bootstrapping. Say you've got a secondary data center hanging out over in Azure, and you have to actually connect it to Google GKE the first time. How does that work? The normal way this would work is that you would just go into the Azure data center, the secondary, and just say, "Hey, join this IP address," and you'd give it the necessary sequence, and it would just dial that IP address directly. It would exchange gossip packets using surf, the layer on top of this the swim algorithm that we have inside of Consul to do gossip. That would do a membership exchange, and you would basically ask, "Hey, what are all of your servers' IP addresses and ports, and any other data centers you happen to know about?" Fetch that down, install it into your own data center, and from there, then you have your entire like phone book of how to dial all the data centers, and then you can just go to town doing RPCs and everything. But as Nicole was showing, like, those aren't even accessible. You can imagine if you just followed some tutorials and using kube ADM to stand up kube clusters, and you kind of glossed over the pod sitter configuration, and you just left the default, then your two kube clusters on both sides, all the pods have actually the same IP addresses. So your servers might both think they're this like 10.0.1.1, and I don't think no amount of network trickery is going to make those be able to talk to each other, because they'd be talking to themselves, right? So that's like the worst case scenario of this sort of setup. Like by definition, you can't get there from here anymore. So in that case, that initial dial out to fetch the phone book of addresses won't work. And even if it did work, all the addresses are wrong, right? The address of the other server is your own server's address, and that wouldn't help you. So what we have to actually do is we dial the mesh gateway. The mesh gateway picks a random server on the other side. It fetches that catalog, but all of the nodes already have an annotation of what data center name it is attached to. We save that locally, and when running in this mode, we kind of just ignore all the IP addresses and ports, because we're not going to use them. They're still there for backwards compatibility if you have any servers joining normally. But this the pivotal thing we're going on is the node name, which is the specific server on the other side of the ocean that we're going to talk to, and the data center name. We talk to that mesh gateway. We can address mesh gateways using data center name. That's the one that's how you know which one you're talking to. In local mode, when you talk to a mesh gateway, it'll even forward you to another mesh gateway on the other side, so you can get out of your data center, hop across the pond, and get into the other data center that way. During bootstrapping, you don't have mesh gateways yet, because you haven't even finished standing up your Consul servers. So until we finish bootstrapping, all of our requests are going to be going directly to the primary's mesh gateway to get in to finish bootstrapping. And finishing bootstrapping basically is like we do that initial exchange, we figure out where all the servers are. The rest of the setup on the other side starts to initialize replication, where we have to start replicating ACL policies, ACL roles, ACL tokens enough locally that the secondary data center can start allowing RPCs to work and start doing stuff like generating certificates for connect services in the data center, or letting you register mesh gateways in that data center. The other trick here is I've mostly been talking about dialing up to the primary, but gossip is point to point. Any random set of servers is going to talk to other random set of servers. So the primary actually has to reach down to the secondary to do gossip and RPC forwarding. And there's no mesh gateway yet on the other side. You haven't finished bootstrapping, right? So like actually during bootstrapping, the primary is trying really hard to dial down and it's super failing. So there's this gray window where the secondary is still trying to catch up enough so that it can stand up its mesh gateway. And we added a new, I'm calling it a cross-replicated piece of data. Every data center records a little piece of data in the primary's data store, which is basically a snapshot of where all the mesh gateways are in that data center. It saves it up to the primary, keyed by the data center name, and then all data centers feed that, replicate that down from the primary. So at the end of the day, barring some lag, all data centers know, and written to disk, not just in RAM, all data centers know where all other data centers' mesh gateways are and their health at all times. So during this gray period, the secondary is, once it gets bootstrapped enough, it can write that up to the primary, which then replicates down to all other data centers. And at that point, everyone can finish having those little loops that trying to dial down, those will stop failing, and everything will finish setting up the rest of the way. Everyone else is going to do their gossip messages. They'll get routed through a pair of mesh gateways, pop out the other side, go through the machinery and do the normal plumbing. RPCs, normal RPC forwarding will work at that point. But yeah, there's the gray period is the weird period, where we're doing some fascinating layer punching.
Nice. That's interesting how that all works. I hadn't quite gone that deep on how all of that gets initiated and started. So that's pretty cool to actually understand. We did have a question come in though about they're new to mesh gateways. And so they're wondering if this is only available if your service is behind the Envoy proxy set up by Consul with Connect, because they like to use a bit more of a bare metal approach or a bare approach using like WireGuard for the interfaces to secure traffic.
So currently, the mesh gateway feature is just a managed Envoy. So just like all the other sidecar proxies, that particular Envoy is making a specific kind of request for configuration data via XDS to whatever agent it's attached to. But the actual mesh gateway itself is just Envoy currently. You don't need to have Connect running. Like you don't have to be using Connect for service meshy stuff to make use of this particular feature. They're just, you can stand them up just for the WAN Federation help. If you weren't planning to actually do a lot of data plane operations across your public internet.
Okay, nice. We had another question about what are folks doing to automate the security hardening of Consul in regards to Ackles and TLS and so forth?
Well, if you're using Kubernetes, the go-to one is the Helm chart, just because if you're going to do it in Kube, you could do it the hard way where you try to figure out how to poke all the right bits to set all the right settings, but you'll end up doing something kind of like what we already did in the Helm chart. And there's like some helper programs that actually inject things in the right way and save stuff in secrets and ship them around and extract them. In the case of the example that Nicole was mentioning, handing off a bundle of secrets to the secondary data center to bootstrap it is actually doing a bunch of work under the covers for you. I'm unclear what people do outside of Kubernetes, because usually everyone has a very unique setup for how they've currently got Consul deployed, because networks are like snowflakes, right?
Yes. There's also, in terms of TLS, you have the option of using Vault to generate all of your certificates if you're already running a Vault instance. Let's see. So in this context, it looks like they're already building Consul and Vault and Nomad on top of EC2 instead of using Kubernetes for the context of this question. So in that case, for your TLS, Vault might be the way to go.
Yeah, there's two different, it's important to point out there's two different TLS setups here that are important. The actual service mesh stuff uses the Connect certificate authority, which is entirely managed internally. By default, the built-in CA is just doing it within the console itself. There's an option to connect that up to Vault and have all the private key material associated with the Connect CA managed in a Vault. Separately, there's the TLS certs that you give to all the console instances so they can communicate with each other. But those are, which you could also then use Vault to generate if you were going to set that up.
Nice. Okay. The other question we have so far at this point is, what are the differences between Istio 1.5 and Consul Connect in brief, and what are possible things that are missing in Consul in comparison?
I have not used Istio.
Okay, that's fair. I have not messed with Istio 1.5, so I don't know exactly what all is included in 1.5 to answer this question either. So I'm not sure that we'll be able to get that for you right now, but we can definitely figure that out and provide some additional information. So RB, anything else you want to add about the new WAN federation through the mesh gateways?
I can't think of anything. Is there anything you want me to add, or that I left ambiguous?
I don't think so. I think that covered everything that I had in mind and more. So,
okay.
So if you're good, we can now hand it over to Kit to talk about the new functionality around the audit logs.
Yeah, so audit logging is a feature that we added in 1.8. In particular, we're audit logging HTTP requests made to Consul. And this is really handy for a lot of enterprise use cases, or just people who are subject to regulatory needs or have a particular desire for just better auditing of when users perform actions on a cluster. So in order to meet regulatory compliance, a lot of GDPR in particular is specific about recording when users do something in a cluster. So that ends up being what authenticated, when did they do it, and what did they do? And if you have those three pieces of information, then you have a pretty solid audit trail, and everything else is just gravy. So when we looked at solving this problem, it was how can we ship something that's sound and meets the regulatory needs? And we ended up hooking into the HTTP layer So every request that you make is instrumented at the start and finish. So if you use like the Go client, or like if you use like Consul like KV and do like a put operation, it'll record that. Any requests made with like Python client or a Ruby client will get recorded, and everything in the UI as well, because the UI communicates within a Consul cluster via HTTP. And that captures sort of the cluster of user actions. So if you are subject to GDPR, which is just about everybody nowadays, or you have like PCI compliance needs, those two pieces of legislation are really particular about like the who, the what, and the when. So it's a pretty simple feature. Like I'm very happy with it. It's like turnkey in a lot of ways, where we give you a couple of fields to fill in. We're extremely explicit about what you have to fill in. So that way you don't end up like, if you try to like set it up quickly, just to get it running, we want to make sure that you aren't able to like accidentally set like too short of a retention policy or something like that. Like, there's not a limit into how long you can take it, or into how long or to how short logs can be retained, but we make you be explicit about every choice that you make, so there's no like hidden behavior there. So it's simple to operate, and it everything's printed out onto a single line. So if you're using like JSON streaming, or like it works with most logging protocols, so it should be simple to sort of pop into what you already use in your cluster. So that's audit logging. It's not particularly exciting, right? Like nobody gets excited about the regulatory compliance out there. Maybe I do after implementing it and now, but it works and it's strict and I'm happy about it.
Nice. That's awesome. It's always good when we have more logs and you can see what's happening within the system, especially for compliance reasons. So it looks like we had some additional questions come in around Service Mesh and Connect. One of them being, so how much of the Mesh Gateway functionality is enterprise specific?
None of the Mesh Gateway functionality currently is enterprise specific. The WAN Federation via Mesh Gateways is totally open source, and Mesh Gateways in general open source. Multi-DC Connect is open source as of 1.6. Yeah.
Okay, yeah. And everything I showed at the beginning, that was all using the open source version of our product, not an enterprise version. So all of that is available and you can stand that up yourself. We had another one that came in with, can you please provide some simplified docs regarding Vault in Kubernetes? For that, I would recommend checking out learn.hashicorp.com and clicking on Vault and then Kubernetes. There's an entire section of guides there for getting started with deploying Vault into Kubernetes. And that would probably be the best starting point for learning about that and getting started there. Let's see, next questions. Are terminating gateways for services within my mesh only? Like if I have mixed connect enabled and not connect enabled services?
So I think, let me describe what that's supposed to be for to see if that actually answers the question. Terminating gateways are supposed to be the way to get out of a mesh gateway and reach some sort of old, the canonical example we've been using is like you've got some really old mainframe that sits in the middle of your insurance company or something like that, that just works, runs who knows what, Ada, I don't know, like some ancient language. But you're not going to move it because it works just fine for doing your air traffic control or whatever. But maybe you've gotten a whole bunch of like new UIs that you've actually not written in Fortran or whatever, because that would be awful. And they need to reach into this mainframe thing, right? And if you've deployed any of those inside your service mesh, how do you reach out without doing some awful VPN thing to get over to your pile of data that you've accumulated? So in that case, you can put a terminating gateway in front of that old resource that isn't going to be migrated into Kubernetes anytime soon or whatever, or to a cloud or whatever. And that way things in the mesh can dial over to your non-mesh object. Presumably something that's running not inside of the mesh could just be arranged to reach that older service directly, as you would with no service mesh. So it's really about getting out of the mesh while still maintaining all of the MTLS stuff.
Okay. Another one was, if my connect enabled service request an external site, will it transparently not use MTLS like for internal traffic? And that's if they opt in for mesh gateways. If they opt in for mesh gateways, when do they need terminating gateways?
I think that's multiple questions. The first one sounds like if someone had their service under the covers, I don't know, like do a curl against google.com, is that going to magically go through it's going to get intercepted, routed through like IP tables magic and proxy? No. If you want to go through all the Consul Connect stuff, you have to use the proxy to dial out to reach something on the other side. Nothing stops you from just dialing something directly. That would be subject to whatever network policy that you've configured in your corporation. I think the second half of that sounded like a different question.
Before you jump to the second half, though, I will point out, it sounds like this question is coming from the use case of having used Istio before. And in Istio, once you get your sidecars, they automatically steal all of your traffic and route it through your Istio mesh. With Consul, when you deploy your sidecar proxy, instead of all of the traffic getting routed through there, you change the endpoint that you're talking to talk directly to that proxy over localhost, so that you route your traffic over the ports that are exposed by the sidecar, rather than all of your traffic going through your mesh network. So I think that might help clarify that one a little. And then, yeah, the second question is, if I opt in for mesh gateways, when do I need terminating gateways?
The two things actually compose. So you could use if the data center that has your mainframe in it is a different data center than the one that has your hot new web app in, the hot new JavaScript web app could go through two mesh gateways to get to the terminating gateway on the other side to get to the mainframe.
Yeah, there seems to be a follow-up question with that one, which is, are terminating gateways for services within my mesh only? And so, like, if they have mixed connect enabled or not enabled services. And so I think maybe it would be good to talk about what exactly the terminating gateways are, because the terminating gateways in Consul are different than potentially the ones that people are familiar with from Istio.
So it's kind of like a non-local sidecar, if that helps at all. You could, in theory, I guess, log into your mainframe and then run a copy of Envoy on it, right? And then you wouldn't need a terminating gateway. But sometimes that sort of thing is not possible. So this is sort of a copy of Envoy that you run within the same sort of security perimeter around the mainframe that you put other sensitive administrative tools. Like you've wrapped your mainframe in firewalls since the day before time, and you put a copy of Envoy on the bridge around that, much like you put your firewall at the bridge to get out. And then it can mediate all that secure traffic to go in. Yeah, so it's sort of it's fulfilling the same role as what a sidecar would do for a regular app, except in situations where you can't necessarily co-locate it on the same physical box.
Yeah. And one of my favorite examples there is like when you have a Cloud SQL database that's provided by your cloud provider. So like Cloud SQL or RDS or Cosmos DB or any of those, you can't actually run that Envoy proxy locally. Oh, dog. And so you have to actually run that proxy somewhere else. And that's where terminating gateways comes into play, as it allows you to add those databases into your mesh without being able to run that sidecar next to the database. So we did have a question come in about the audit logs, which is where do the logs go and how do you configure that?
Yes. So currently, or not currently, like this probably won't change ever. In order to enable logs, you require at least one sync, and a sync can have different types. And currently, the only sync we support is a file sync. So you say, I want to sync, that's a file, and the path that it will go to can be anywhere. You know, like you can choose a directory. You can pick a specific file name if you just want like an endless file, or you could pick like standard out or like standard error if you wanted to. You could define both. Like we support end syncs if you wanted to like make sure that you're writing out to like your local drive and like maybe a replicated drive somewhere else. And if you want additional syncs, that like absolutely ask for it, because if you want to just like write directly to, you know, a Kafka topic, or like SQS, or, you know, if you want just to like send UDP on syslog, just like let us know. We'll build it if there's interest there. But where the logs go is where you tell the path in the file sync.
Nice. Okay. We also had a question come in earlier about, are we doing any work to make it easier to bootstrap the Hashi stack on bare metal? Is any of that on the roadmap? For example, like providing Ansible roles to start. I know some of the answer for Consul, which is in Consul 1.9. We are doing some work to help with automating the configuration for when you stand this up. So pulling some of that stuff that RB mentioned that's in the Helm chart, starting to pull some of that into the main process so that you can actually do that outside of the Helm chart a little easier. I know there are community provided Ansible roles, but I don't know of any efforts ongoing to provide Ansible roles ourselves. So our next question is, with Consul Connect and mesh gateways, does Consul Connect native workloads across, does Consul Connect natively work across mesh gateways if the destination proxy is not reachable directly, but rather only via the mesh gateway?
Okay. It's not reachable directly. I'm not sure what this question is asking.
Looks like there was a follow-up point there with, or maybe an additional question, but it's, if I'm using Consul Connect with Nomad, doesn't that prohibit cross-service networking, allowing it only with Connect?
If I recall correctly, the Nomad integration is such that you have to opt in to using Connect on a job-by-job basis. So you can, it's not like you're flipping a switch and then everything in your Nomad cluster has to go through Connect. That's all this stuff is sort of made around the gradual transition from whatever you were doing before to your end state.
Yeah, and with that, you've enabled that switch, and that will give you your connect sidecar, but it doesn't do anything to impact or limit communication between services directly if you don't want to use the sidecar. So this is when they're, so for the first part of that question, it's when they're WAN federated. So I think the question is, if I'm understanding the question correctly, it's you've got the WAN federation through the mesh gateways, and you've got proxies on both sides that are only reachable through the mesh gateway and different subnets that can't communicate with one another. Does that communication still work?
Yes. So much like the description I said earlier about how the servers solve the can't get there from here problem, individual workloads like your web service talking to your backend service and two different data centers, the web service is configured to say, oh, I want to talk to the database service or the backend service in the other data center. It does the correct catalog query to know that, oh, I have to take a trip through a mesh gateway. So the Envoy cluster that's configured actually points to the mesh gateway. If you're in a situation where the network addresses on both sides have the severe overlap that I was describing before, that's when you would use the mesh gateway local mode, which means that you're going to take 2 hops to get to the destination. There is a variant where you can do remote mode, which is 1 hop, which means you just dial directly across the network and just come in on the mesh gateway on the other side first. But in the local mode, you take the 2 hops to get out, and then the mesh gateway on the other side makes sure you get to the final destination. So you can have 2 things that technically have the same IP address, a front end and a back end, in different data centers actually still talk to each other.
Yep. And so with the follow-up comment that came in, there's a little bit of a delay between the Zoom and the YouTube stream. So it was so on different subnets, one thing can't reach the other. The mesh gateways can over WAN, but the apps cannot without the WAN gateway. And that is correct. That is how that works. The other question we've had come in is, what tools do folks use to write and manage Ackles? And is there a preferred IDE or any tooling that's preferred?
So Harvey, you might be able to, you might know more than me on this one. So I probably hand off the question, but I don't think that we have any like syntax highlighting or something for our Ackles setup.
I don't remember where I forget if it's a HashiCorp maintained thing, but I know for like the VI editor, there is an HCL syntax formatter that at some point I enabled for my own config. You can also make it trigger I think the HCL2 source tree has a command binary to do like an HCL format, so it'll like re-indent everything correctly on file save, which is kind of convenient. That's just for the rule portion of the ACL. If you actually knew what the rules were, but you wanted to make sure that you enforce them correctly, we have the Terraform, I forget the right word for it, provider module, to actually let you remotely administer enforcing rules and policies and roles and tokens and whatever are created as per what you've written down.
Very nice. The next question that came in was, is there a recommended way to back up Consul's open source community edition? And so do we recommend running periodically the Consul snapshot save command using the API endpoint, or backing up the underlying volume?
The snapshot save command is the one that is kind of reach into the state machine and actually extract stuff in a sane format. And restoring it is still like a disaster has occurred, right? So I think we have docs on the disaster recovery kind of setup where you're restoring this from a backup. You could snapshot the file system, but restoring from a file system backup is a little trickier just because of the way the Raft database tracks its own identity inside of the disk. So when you bring it back up, it'll potentially get a little bit confused if it comes up attached to a node with a different name. There's ways around it. It's just a little bit easier if you use the snapshot save restore rather than a disk save restore, or there's less hand-holding required for that.
Okay, nice. So why was it chosen to re-implement Envoy configs subset in Consul HCL? It's a lot nicer, but it's only a subset. And then also kind of a follow-up with that is, will more of Envoy's possibilities be reachable with the HCL configs in the future?
So the first version of all this, I think, was in 1.2 or 1.3, and actually Envoy was not related at all to this. And it was just, we had the built-in proxy, which was for kicking the tires, written entirely in Go. Much reduced syntax, what you could do with it, because it was all layer 4 connectivity only. The Envoy one was added as a, well, if you're going to run this in production, please don't use this binary that we wrote for this built-in proxy for kicking the tires. You should use something that actually is built for this. But like a bunch of other HashiCorp tools, we're trying not to pin you to a particular vendor. I know there's a different company that was had open sourced their integration where they were, instead of using Envoy, they're using HA proxy for implementing the same thing. I think that was done before the 1.6 release, where all the additional L7 configuration was added to our integration right now. So there's a little bit of a lag on things that are not currently Envoy. Even our built-in one doesn't support a bunch of that stuff right now. So if you wanted to get all the feature completeness, you should use the Envoy one right now. And on the second question, because we're trying to not overly encumber ourselves to the specifics of Envoy and try to, there's a lot of different things you could do with Envoy, and there's a lot of documentation for how to do those things in Envoy. So we're trying to make it slightly easier to do the things that we think you should be doing with Consul, that should be easier to do rather. So make the easy things easy. And for I think the 1.3 release, we had exposed some things we were calling escape hatches, where you could decorate some of those configs with arbitrary collections of Envoy knobs if you needed to do something that wasn't currently supported. And as we find other things that make sense in to expose in a way that is not like pinning it directly to Envoy syntax, we've been adding some of those. I think we added one about rate limiting. I might get that confused in the 1.8 cycle too.
Okay.
Yeah, so that one's interesting to me. That this was like well before I joined HashiCorp. That the Consul Connect was designed as an abstraction over like any kind of like service mesh provider. Do you know if we're still having not like really worked close to the service mesh stuff? Do you know if we're still open to supporting other just like transport layers, or are we just like full on Envoy?
Last I checked, we were still. I know the HA proxy one is still in flight. Yeah.
Okay. I think that's a neat design decision, just to like, I guess, toot our own word for a second, giving sort of users the option to plug in and sort of add complexity where they need it, but also give them a simple abstraction where they just need sort of the paved road.
Yeah. So we're getting close to time, so we've got time for probably just one more. And it looks like there's a follow-up for this last one, which is the HCL config just translated to Envoy config? And if so, is there a way to directly console config write Envoy YAML config somehow?
it is not directly translated. If you we hang everything off of these things called config entries, which are little documents that like you make one to describe how to do a split, like an A/B split where you're sending 10% of your traffic to one flavor and 90% to another flavor. Under the covers, that gets put in particular places in the Envoy config. It sets up how you do the cluster and how many clusters you need to set up and where do you map that into the HTTP router. I think that's what it's called. And that's relatively simple to map, but it doesn't necessarily align, like the Consul data model doesn't necessarily align with the specific data model of the whole XDS thing that Envoy has. As an example of that, like the failover construct that we implemented is a lot trickier to map down into Envoy to say, when all these things stop working, send all my traffic to this other thing. There's a way to do that in Envoy, but composing that with all the other things they wanted to put in there it's not a perfect mapping.
Okay.
So we've had future like HashiCorp features like roadmap questions, like requests to add stuff come up a few times. So we would absolutely love to hear the stuff that you're interested in. So that way we can schedule it, and ship it for you. I think GitHub is probably the best place to ask, and Discuss is also a fantastic place to ask. So people, like we have people there who are like going to engage with you about it and make sure that the people like RB and I who are implementing it know that it's valuable to you. So head on over to GitHub and Discuss. We'd love to hear your ideas.
Yeah, and with that, we're at time. But I just want to remind everyone that on June 22nd through 24th is HashiConf Digital. It is our digital event that is happening during the European time zone hours during the daytime for that time. And we also have a Consul training available during that so that you are able to learn more about securing your Consul data center if you're interested in that. And then, make sure you check out learn.hashicorp.com so that you're able to see and get guides to walk through all of the content that we talked about here, as well as Kit mentioned, discuss.hashicorp.com for community forums to discuss issues or anything you're having with engineers and the rest of the community. And thank you, and